So it says, given the triangle XYZ, calculate the value of sine x. So again, with all geometry problems, I like to draw a diagram. This here is x, this here is y, this here is z. And this is nice because this is here is a right triangle. And it says here this is 3 units, and this side here is 5 units. And what we want to do is find the value of sine x here. And this here, I guess, is our small x. So I'll say this here is angle x here. And we want to calculate the value of sine x. So what we can do first is let's use our trigonometric ratios, and let's see if we can actually just immediately solve for it, right? So usually I use a mnemonic called the SOHCAHTOA. So SOHCAHTOA, and what this is it's a mnemonic for some primary trig ratios, right? So S here is going to be sine is equal to opposite over the hypotenuse, cosine is adjacent over hypotenuse, and tangent here is opposite over adjacent. In this case here, we care about sine, right? So this here is sine is going to equal the opposite side over the hypotenuse. And we want sine of x here. So if we look at here, sine x here is going to equal opposite of hypotenuse. Well, the opposite side is, well, I'm not given this side, right? This side is unknown. I'm going to say that this here is equal to the side yz is, or yz is unknown, right? So this here is going to be yz over the hypotenuse, which is given to us as 5. So we now have written a sorry, this is sine x. We've now written an algebraic expression to solve for sine x here. But again, we're missing some type of information because we're not given our angle here, and we're not given our yz here, right? So what we have to do is solve for yz. And how do we do that? Well, we can use the Pythagorean theorem to solve for yz, because this here is we have a right triangle, and this here we have 2 sides, which means we can algebraically solve for the third side here. So let's say that I'm going to say that for the sake of Pythagorean theorem, I'm going to use xz squared is equal to xy squared plus yz squared. And this here is what we're looking for, because yz squared is the side we're looking for. Well, we know that xz is equal to 5, right? So this here is 5 squared is equal to, well, I know xy, also the length of xy is equal to 3, right? So we can say that this is also equal to 3, and then we square the value. This is y squared. So we have 5 squared is equal to 25, is equal to 3 squared, which is 3 times 3, which is equal to 9, plus yz squared. And then I can algebraically isolate for yz squared, right? So we can say that we can minus 9 from both sides to get 25 minus 9, which is going to equal 16, is yz squared. And then we can square root both sides to solve for this problem, right? So I would have the square root of 16 is equal to square root of yz squared. These two guys cancel out. So yz is going to be equal to the square root of 16, which is going to equal 4. And in this case here, it's technically root of 16 is equal to plus or minus 4, but in this case here, a negative value would not make sense, right? Because how do you get a negative length in our triangle? So what we can do is we can actually say that because negative 4 is not valid, is not a valid length, we use positive 4. So in this case here, we neglect this value and say that this is only equal to 4. So yz then is equal to 4, which means I can solve for sine x, right? So the ratio of sine x here is sine x is equal to, again, hypotenuse, opposite of hypotenuse, which is yz over hypotenuse, which is 5. And we know that yz is equal to 4. So we can say that sine x is going to equal 4 over 5. And this here is our solution. So therefore, I can say that sine x is going to equal 4 over 5. And this here is our solution for this problem. So again, as you can see, sine x is equal yz over xz. which is a hypotenuse. I wrote this as a hypotenuse, which is fine. But it's, again, the same value, right? 4/5 is the required value. So the solution here is correct. I like what they did here as well, because yz is equal to 4 units, since distance cannot be negative, right? So I said since -4 is not a valid length, because you can't have a valid length, therefore you only take the 4 value, the positive value here. So the solution here is correct.